record. We're recording now. And I'll go to sharing the screen. I can get to that. And then we'll get started. Okay, so my original goal yesterday was just to do introduction. I did more than that. I snuck in a little bit of 1.1. Sorry, I think I mentioned it the other day, but this thing, for some strange reason, tends to turn yellow once in a while. I don't know why, but if I go like this, it goes away. Okay. And sorry, I know sometimes it doesn't seem like it focuses. I have no focus button on this. Okay, and you might complain. I would complain too. I'd like to get a new document camera. Okay, I notice if I go like this, it focuses better, but that means I have to lift up my paper or the book. I might be able to lift it up for a little while, but I can't write like this. And certainly I can't hold the book up that long because the book is heavy. Okay, so I apologize ahead of time for that. But that's the way that's going to be. I did send the video. Okay, so if you didn't already get a chance to look at the video, by the way, you're not required to look at the video. You say, I already, I saw him in class and everything's fine. You don't have to look at the video. You're not getting points for looking at the video, but maybe you want to review the video later. So I usually send the video through Canvas announcements, or those of you that are trying to add, you can't get Canvas yet, so I'll send it to your email. So that's what's happening. Okay, so I'm continuing on with 1.1. Okay, so I got up to problem 10. I'll try to do a whole bunch more of this. I think I can do a lot more because yesterday I did a lot of introduction stuff, right? But now I don't have to do any introduction, so we'll just go on with problems. Okay, so here we go. So I got up to roughly 10. Let's look at problem number 13. Okay, I'm trying to hold the book up so you can see it better. Okay, 13. So I'll do 13, you do 15 on your own, which are assigned. 13, you put some ice cubes in a glass, fill the glass with cold water, and then let the glass sit on a table. Okay, I want to point this out to you like that, but I can't. I need both hands to hold the book up. Okay, it'd be nice to have a third appendage, I guess, but I don't. Describe how the temperature of the water changes as time passes. Then sketch a rough graph of the temperature of the water as a function of the elapsed time. Okay, so you have ice cubes in a glass, put cold water in it, and let it sit. What happens to the temperature? Okay. All right, so here's what I have for us. All right, so at first, you're at so-called room temperature. And then because of the ice, the temperature goes down to 0 degrees C, which is the freezing point of water. I think a lot of you know that. If you don't know that, you know it now. Maybe you had that in chemistry. Okay, so water freezes at 0 degrees C. Okay, and here's a property that you may or may not know from chemistry also. But okay, so you have a combination of water and ice at 0 degrees C. Okay, you chemistry people know this, but as the water ice combination eventually turns to all water, right? So the ice will melt and turn to water. It stays at 0 degrees C. Okay, so you've got the water. Because of the ice, it eventually goes from room temperature, let's say it's that, it goes down to 0 degrees C. Then as time goes by, the ice turns to water, but it stays at 0 degrees C. Then as more time goes by, it's all melted, and then it will start to go back up. The temperature will go back up after all the ice melts, and then we go back to room temperature. Okay, so what does it say here? The temperature goes from room temperature down to 0 degrees C, stays at 0 degrees C until all the ice melts, then goes back up to room temperature. Okay, so here's a rough sketch. Okay, notice this is very qualitative, not quantitative. Okay, here's time, although this is 0, temperature degrees C. So it drops down to 0. It stays 0 as the ice melts. Then the temperature climbs back up, but doesn't go up indefinitely, right? Once it reaches room temperature, then it stays at room temperature. So I have it leveling off, and it levels off back to roughly room temperature again. Okay, so that's what I have for problem 13. All right, so that was 13. You do 15 on your own. Okay, and I guess for those of you trying to add, you should try 15 on your own. Here it is. I showed it to you yesterday also, but in case you need to look at the video, here's problem 15, and it asks you some questions about 15. Okay. All right, and let's see, 27 to 49. There goes the yellow again. Okay, so let me do some 27 to 49 stuff. Okay, I'm on page 21. Evaluate something called a difference quotient. Okay, so evaluate this funny expression for the given function. Okay, this looks pretty quote unquote bad. Get used to this. We're going to see this expression over and over and over in our class. Something called a difference quotient. Okay, so what is difference quotient? Well, difference means what? Subtraction. Quotient means division. So like this one. There's a quotient, there's a minus sign, and a minus sign. Okay? That will happen quite a bit, so we're just setting you up for it. Okay? Quick reminder, all of chapter 1 is pre-calculus. So the first exam is really a pre-calculus exam. Okay? We don't do calculus per se until chapter 2. Okay? So everything here should theoretically be reviewed. All right, so f of x is 1 over x. Find this funny thing, f of x minus f of a divided by x minus a. Okay, so let me show you how to do 29 for you. Got that over here, please. So f of x equals 1 over x. I can raise it up a little bit. So f of x minus f of a divided by x minus a. Okay, all right, well, f of x is just 1 over x minus, it says f of a. What is f of a? You don't have to answer, just think to yourself when I say stuff like that. That means you put an a right there, 1 over a. And divide the whole thing by x minus a, it says. Okay, so I have this expression right now. You don't leave your answer like that, though. I mean, that looks weird. You don't have a fraction on top of a fraction. That looks too weird. So how do I simplify it? Well, what's a good common denominator for these two? Common denominator is ax. So what you do is multiply the top and the bottom by ax or xa. So if you can't read that, that says x times a. So the denominator is x minus a times xa. Okay. Now, if I multiply by xa, you'll get a cancellation here and here. So what are these little lines here? It means 1 over x times xa, and then negative 1 over a times xa. Okay. Now, if I take this times this, what cancels out? X. So you have left a. Minus, what happens when you take this times this? What cancels out? A. So you have x. So when I take this times xa, I now have a minus x over x minus a times xa. Okay. Now, here's a trick you may or may not recall from algebra, but a minus x divided by x minus a, that can be done, but it's not 1. It's actually negative 1. Okay? If you want to make a little note of something like that, anytime you have something like a minus x divided by x minus a, it's negative 1, not 1. They're not equal. So final answer is, I messed up here. Final answer is negative 1 over xa. Okay, so again, a little sidebar here. Anytime you have, how about I'll put a minus b divided by b minus a, it's equal to negative 1, not 1. And that's provided a and b are different. If a and b are equal, like if they're both 7, then you're dividing by 0. You can't do that. Okay, but this is always going to be negative 1. And example, suppose 7 minus 5 divided by 5 minus 7. Right? What's 7 minus 5? 2. What's 5 minus 7? Negative 2. So if you divide them, you get negative 1. Okay? That's always going to work. How about, let's say, 3 and 10? 3 minus 10, negative 7. 10 minus 3, positive 7. So when you divide, you get negative 1. Okay, so bottom line, this stuff here cancels out, leaving me with negative 1. So the answer is negative 1 over xa. Okay. All right, so that was 29. You do 27. And those of you trying to add, do 27 for homework. Yes. Okay, and now 31 to 37, find the domain of the function. Again, you might be saying to yourself, hey, it sure looks like he's doing a lot of the problems. I am. Okay? I'm shortening your assignment. So remember I say you have to turn in at least 70% of this. I end up doing what, 30, 40% of the homework anyway, so you have a lot less to do. You just go back and review the stuff. Okay. Find the domain of the function. Domain is a set of all possible x values or input values. Specifically, I say x, but this looks like t and p or whatever. Okay, well, what might be trouble? Well, you know that if you have a fraction, you cannot let the denominator be 0. You can't take the square root of a negative, for instance, right? So all of those are things to watch out for. I'll say something quickly about 33. And let me raise up 33. It's a cube root. Yeah, 33. So I'm not going to write it, but I don't think I have to. Question. Can you take the cube root of a negative number? You know you can't take the square root of a negative number. Okay, again, for our class, everything we're doing is real numbers. No imaginary stuff like the I. Remember we had a plus bi. Like you might say, oh yeah, square root of -4 is -1, so 2i, right? We're not going to do any imaginary stuff in our class, all reals. Can you take the cube root of a negative number? Like, what is the cube root of -8? -2. So you can take the cube root of a negative. So for 33, the domain is all real numbers. Okay? You don't care about that 2t minus 1. Sorry, I can't point it out because I don't have any more hands. Or maybe I can quickly go like this. Okay? It doesn't matter if 2t minus 1 is positive or negative. Okay? You can take its cube root. So 33, the domain is all reals. And for all real numbers, you can use the funny looking r. Okay? Are you familiar with the funny looking r? Okay, so that's all real numbers. Okay. So let me do something that isn't all real numbers. Okay. 31, here's the function. X plus 4 over x squared minus 9. Okay, so what's the domain? Okay, so ordinarily you would say, well, start with all real numbers, and then you say, aha, there's a fraction. A fraction is never allowed to be 0. So I set the denominator equal to 0, solve for x, and then that gets thrown out of my domain. So what about the numerator? You don't care. The top can be 0 or it can be non-zero. Doesn't matter. So in fact, it doesn't matter what this is. Well, as long as you're doing something like a square root or a natural log or something with trig, you might run into problems. But for a polynomial like x plus 4, it doesn't matter. You're in no trouble. Okay. So I basically solved x squared minus 9 equals 0, which is not too hard to do. Okay. So x squared minus 9 equals 0. Simple factorization, that's a difference of two squares. X plus 3, x minus 3 equals 0. Right? Which means either this thing is 0 or this thing is 0. It's focusing a little better because I'm raising up the paper, but I'm willing to raise up paper. It's not that heavy, but not the book necessarily. Okay, so by the 0 factor property, either this is 0 or this is 0. So what number makes this thing 0? -3. What number makes this thing 0? +3. So x is plus or minus 3. Okay. So in other words, if I plug in either 3 or -3 right here and here, but of course here you don't care. If I plug in either 3 or -3, when you square it, you get 9. And 9 minus 9 is 0, right? So that's a mathematical no-no. So even though I took a little time out and solved for this, I really want to throw that out of the domain. Okay, so here's how I'm going to write the domain now. The domain is the funny-looking R, which stands for all real numbers, minus the set consisting of -3 and 3. So these are braces. They're not parentheses. They're not brackets. They're braces. So braces indicate that you have a set. Okay. So we already know about brackets, right? Like a closed interval. And you know about open intervals. Okay. But for braces, it's indicated a set. So this means all real numbers except for -3 and 3. By the way, if you look in the back of the book, it might say something funny like -infinity to -3 union -3 to 3 union 3 to infinity. That's actually the same thing. Okay. And don't worry about what I said. It's much more difficult to say that. Okay. So if you want to know what maybe the back of the book says, they go like this. -3, 3, open circle, right? And then shade all this, shade all this, shade all this. So how could you say it? I guess you could say from -infinity to -3, union -3 to 3, union 3 to infinity. Okay, that's correct, but it's so cumbersome. Isn't this a lot easier? Just take all the real numbers, throw out -3, throw out 3. Here it is. Okay, so just punch a hole here, punch a hole here. So -3 is not allowed, right? +3 is not allowed, but every other number is allowed because I won't be dividing by 0. And you don't care about the top. The top's going to be fine. All right, then 37, I will show you. 37, f of p is the square root of 2 minus the square root of p. Okay, that gets a lot more clumsy because there's a square root inside a square root for 37, right? So how do I do that thing? I don't know why it's yellow again. F of p is the square root of 2 minus the square root of p. Okay, something I will say often is sometimes if you don't like to look at something, don't look at it. Just cover it up, so to speak. Say, I'm scared, I'm dizzy with all the square roots. Okay, well, let's take it slowly. Suppose I look only at that, square root of p. Yeah, I can handle that. So right here, what has to be true about p? What kind of number can be in the p? Or maybe I should say, what number is not allowed for p? P cannot be any negative number. Right? Can't be negative. Is 0 allowed? Can I take the square root of 0? Sure. What's the square root of 0? 0. I can put any positive. Okay. So first, I'm going to say p is greater than or equal to 0. Okay. That's just from this part right here. Right? Square root of p. So even though I look at this great big thing with a square root inside a square root, say I'm dizzy, it's too confusing for me, and just take it in parts. Square root of p. Okay. I cannot plug in any negative number. Agreed? Okay, so if I even look at all this stuff, I don't care. I cannot plug in -1, -5, -pi, not allowed. P greater than or equal to 0. Okay, now the harder part. I'm dizzy. I don't like looking at the square roots. Okay, then don't even look at it. There's another square root. Let me just cover up the inside with my ruler here. Okay, so I have the square root of something. There's that something. Yes, it's got a square root. It makes me dizzy. Don't even look at it. Okay. So suppose I just look at this. By the same logic I just had, whatever's behind my ruler here has to be greater than or equal to 0. So this big mess cannot be negative. So this expression behind my ruler also must be greater than or equal to 0. There it is. 2 minus radical p must be greater than or equal to 0. Does that make sense? Okay. The thing behind my finger must be greater than or equal to 0. Okay. What is the thing behind my finger? 2 minus radical p. There it is. 2 minus radical p greater than or equal to 0. Does that make sense? That's what I mean sometimes by saying, if you don't like looking at something, don't look at it. And just go like that. And then I say, okay, now I work on that. So I solved that. So add radical p to both sides. 2 is greater than or equal to radical p. Square both sides. 4 is greater than or equal to p, or p is less than or equal to 4. All right, now both of these have to be true. P is greater than or equal to 0, and p is less than or equal to 4. Well, that gives me this. 0 is less than or equal to p, less than or equal to 4. So that's my answer. In interval notation, I should say, how do you write it in interval notation? I want you to be comfortable with interval notation like this. I did yesterday, right? Bracket 0, 4, bracket, which means count 0, count 4, and everything in between. So this is the domain. Stuff between 0 and 4, count 0, and count 4. Okay? We're finished with the problem, but let me dig a little deeper. If I plug in 0, what's the square root of 0? 0, that's okay. So I have 2 minus 0. I get the square root of 2. That's okay. What happens if I plug in 4? Let's try 4. Plug in 4. What do you get? Square root of 4 2. 2 minus 2, 0. Square root of 0, 0. That's good. I cannot plug in a negative number. Negative 1 is not allowed because of this. I cannot even plug in a number slightly bigger than 4. 4.1 is not allowed. Let's think about it. Plug in 4.1. Square root of 4.1, I don't know what it is, but it's a little bigger than 2. Agreed? Square root of 4.1 is 2. Let me just say 2.1. 2 minus 2.1 would be a negative number. And you cannot take the square root of a negative number. So that seems to fit. So that works. Okay. Okay, so those are some domain functions. Looks like I did 3 out of the 4. So the only one, 31 I did, 33 I kind of did, 37. So the only one left for you to do is 35. So those we're trying to add, do 35 at home. You can't see it. It's 1 over the 4th root of x squared minus 5x, I guess. Okay, and then now, piecewise defined functions. 39, I'll just talk about quickly. What's the shape of this? Hint, y equals mx plus b. It's a line, right? Linear. Slope, y-intercept. Not very convenient numbers, but it can be done. So the domain is all real numbers. So how do you write all real numbers? That funny looking R. Sketch the graph. You don't have to graph it that accurately. It's not a very convenient slope, not a very convenient y-intercept, but just a rough sketch. I do want to talk about 41 and 43. These are piecewise defined functions, right? Remember piecewise defined functions in pre-calc maybe? Okay. So 41 and 43 are assigned. I will show you 41 and you do 43. And those of you trying to add, do 43. Okay. And they say evaluate f of whatever. Okay. So 41, I've got it here. Well, maybe I should write down the function also. So let me write it again. Whoops. F of x is equal to what? X plus 2. If x is less than 0. 1 minus x if x is greater than or equal to 0. Okay, so I've got it written down here. Both of these are linear, straight lines. Okay. This one doesn't have the line underneath it. This one does. Okay, so I'm going to plug in 0 to the top. If I plug in 0, I get 2, but it's not really there, so that's why I have an open circle at 0, 2. Okay, open circle there. Let me raise it up for focusing purposes. I know it's linear, and what's the slope? 1, which means it goes up at a 45-degree angle. So there it is. Okay, so if we were back in algebra 1, right? And it just says graph y equals x plus 2, y-intercept is 2, slope is 1. So you would draw this entire line, right? So I'll just make it go all the way here. But it says x is less than 0, so I don't graph anything there. I don't even count here, open circle, but I do have this. And then when x is greater than or equal to 0, I obey this rule. 1 minus x, or negative x plus 1. Okay, what do you get when you plug in 0? 1 minus 0 is 1. This time it's a closed circle because I am including 0 in this section here. And what's the slope of this guy? Negative 1, which means it goes down. So there it is. So here's the graph. Piecewise defined, so it's disconnected. Later on, we'll use the language not continuous. Okay, you don't have to write that down now, but we'll get that later. So this function is not continuous at x equals 0. Okay, it's continuous here. Continuous, you got to jump up to keep the graph going, and then after that, it's continuous again. So we would say the graph is not continuous or discontinuous at x equals 0. Notice it's still a function because it does pass what special test? It passes the vertical line test, right? If I draw a vertical line anywhere, it's only going to touch at one point. Okay, then it asks for f of certain values. It asks for f of -3. That's a -3 there. Sorry, can't read my writing. Okay, -3. Do I obey the top rule or the bottom rule? -3. Less than 0, I obey the top rule. So -3 plus 2, -1. Then it asks for f of 0. F of 0, do I obey the top or the bottom rule? It's the bottom. X is greater than or equal to 0. So I plug in 0 here. 1 minus 0 is 1. So f of 0 is 1. And then f of 2. F of 2, I obey the bottom rule. 1 minus 2 is -1. So there we go. Okay, if you want to know this other stuff, this was problem 4, which I gave you yesterday. And problem 8, I gave you yesterday, and 10. And there's 13. Sorry, it's a little bit out of order. That's okay. And switch to yellow again. I don't know why, but here we go there. Okay. Okay, 45, 47, 49. Sketch the graph of the function. Okay, and it looks like some of them have absolute values there. Okay, so I'll do 45. You guys try 47 and 49 in a similar fashion. Maybe not quite the same, but somewhat the same. Okay, I'll do 45. X plus absolute value of x. X plus absolute value of x. Okay. Sometimes if you have no idea what to do, make a table. -3, -2, -1, 0, 1, 2, 3. Let's do the easy part. Let's plug in 0. What do you get when you plug in 0? 0 plus 0 is 0. Okay. And then the easy ones are the positive ones, 1, 2, and 3. What's the absolute value of 1? 1. Absolute value of 2? 2. Absolute value of 3? 3. So what happens when you plug in 1? 1 plus 1, 2. Plug in 2. 2 plus 2, 4. 3 plus 3, 6. Right? Okay, so what about the negative values? Think about what happens when I plug in -1. Okay, put -1 here, -1 here. What's the absolute value of -1? 1. So you would have -1 plus 1, 0. Try the same thing with -2. Put a -2 right here, -2 right here. Absolute value of -2. 2.
2.
-2 plus 2, 0. Same logic for all of them. Same logic for -3. Same logic for -1,000,000. Put -1,000,000 here, -1,000,000 here. You would have -1,000,000 plus 1,000,000, 0. There's the graph. It's constantly 0 here, and then it starts to go up. If I plug in 1, you get 2, 2, 4, 3, 6. So it's almost like a piecewise defined function. Okay. So that's that one. By the way, this one would be piecewise, but it's continuous everywhere. Again, we'll use the word continuous later. Okay. So even though it switches direction, there's no gap or jump here, right? So where's that other? Yeah, this one we would say is discontinuous and not continuous at x equals 0, but it's continuous everywhere else. This one's continuous everywhere. I'm just sneaking in some words that we'll have to learn a little bit later on. Okay. Okay, then let's see. Find an expression for the function whose graph is a given curve. What time is it? Almost 9:45, so I'll go a little bit longer, but not too much. Okay, so 51, the line segment joining the points 1, -3, and 5, 7. That's something you should recall from your algebra. First, find the slope, y2 minus y1 divided by x2 minus x1, right? Then after that, do the point slope form. Okay, so y minus y1 equals m times x minus x1. Okay, I know I'm saying it kind of fast, but you've heard all of that before. Okay, try 51 on your own. Okay, 53 is a little bit tougher. The bottom half of the parabola x plus y minus 1 squared equals 0. Okay, so why did they say the bottom half? Okay, this is going to be a parabola. Okay, it actually opens to the left, so it's U-shaped going like this. You don't actually have to graph it though, but you may have done some of that in your pre-calc class. Okay, essentially what they want you to do is solve for y. So I'll show you 53. Okay, x plus y minus 1 squared equals 0. Before I do that, a quick reminder of the square root property. How do you solve x squared equals 9? By the square root property. Now, at first glance, you might say, oh yeah, square root, the answer is 3. Not quite, because negative 3 also works. Remember, you have to do a plus or minus. X squared equals 9. X is plus or minus the square root of 9. And so your solution set is plus or minus 3. Right. By the way, you know negative 3 works, because what's negative 3 squared is also 9. Okay, so how do I solve this for y? Okay, subtract x. Y minus 1 squared is negative x. Then I do the square root property. Ordinarily, I would take the square root of both sides, and same thing, I'd have to do plus or minus. But the text said bottom half. Okay, 53. Bottom half of the parabola. The bottom half means you want the negative. If it's at the top half, you want the positive. Since it says the bottom half, negative. Okay, so I'm doing the square root property. Normally you would say plus or minus, but since it only said the bottom half, put the minus. Then just add 1 to both sides. So here's my final answer. So f of x is equal to 1 minus the square root of negative x. That's it. Okay. In case you're wondering, the problem's finished, but I'll dig a little bit deeper. You might say, how can you have negative x? Okay. Okay, cover it up. The thing behind my finger has to be greater than or equal to 0. Can negative x be greater than or equal to 0? Yes, if x is a negative number or 0. So here your domain would be non-positive numbers. That means you can plug in 0, negative 1, negative 2, negative 3, negative 80, negative 1,000,000. Okay. So sometimes this trips people up, especially in algebra 1. So how can you have the square root of negative x? You can't take the square root of a negative. That's correct. But if x is a negative number, like if x is negative 4, right? You'd be taking negative 4, which is then positive 4. Okay. A little bit weird. Okay. And then let's see. I think I'll show you 59 and then I'll stop there. Okay, so we're getting quite far. Okay, so tomorrow I'll just do the rest. This will not take that long. So I'll finish the rest of 1.1 and maybe sneak in some of 1.2. Okay, so 59 in the last few minutes. Okay, so let's say those of you trying to add everything up to 59. Okay. Of course, don't redo the stuff that we did yesterday. Okay, so maybe for those of you trying to add, we got up to 10. So 13 through 59, anything that I didn't, that I didn't do, go ahead and do those, as it were. Okay. Express the area of an equilateral triangle, 59, as a function of the length of a side. Okay, so how do you do that? So here's an equilateral triangle. Raise it up a little. S, S, and S. We know the formula for the area of a triangle is 1/2 BH. All of these are S. So I'm going to draw a perpendicular straight down. That means this is going to be 1/2 S. Right? Okay, now look at this triangle right here. I have a right triangle, which means it satisfies the Pythagorean theorem. right? So h squared plus 1/2 s squared is equal to s squared, right? H squared plus half s squared equals s squared. Turns yellow again. Okay, what's 1/2 s squared, 1/4 s squared? Subtract 1/4 s squared on both sides. Okay, pretend there's a 1 there. So 1s squared minus 1/4 s squared is 3/4 s squared, right? 1 minus 1/4 is 3/4. Square root property, square root. This is distances. So for distances, you don't need to have plus or minus, right? There's no such thing as a negative distance. So I just take the positive square root. So h is the square root of this mess. Well, the square root of s squared is s. How about the square root of 3/4? Square root of 3, leave it alone, but the square root of 4 is 2. So s radical 3 over 2. That's the height. Okay, now for the area, do 1/2 base times height. So here we go. 1/2 base, the base is s, and the height is s radical 3 over 2, which we just figured out. See, I had to figure out what the height was, right, for an equilateral triangle. All right, so I multiply this all together. Final answer is 1 times s times radical 3. That's s squared radical 3 divided by 2 times 2, which is 4. Okay, so here's the formula for the area of an equilateral triangle with a side length of s for side. Okay, so if we have an equilateral triangle, they're all s. The area is s squared radical 3 over 4. And there we go. Okay, that's that. We have about 10 minutes left. Let me look at the chat. Okay, so bear with me. Okay, so yeah, my lectures are basically just like this. We're doing homework problems if somebody asks for that. Okay, so you're teaching yourselves, well, I'm showing you how to do the problem. So that's basically that. Quizzes are like the homework. All right, that's fine. Homework problems are being examined, similar types. Okay, thank you. Those of you that had me last time, you can vouch for me, I hope. Okay. Do not do anything with the top half of the fraction. I think you're talking about finding the domain. Is that what you mean? Right, so like this one, as for the domain. So I don't care if the numerator is 0. You're allowed to have 0 on top. You just can't have a 0 on the bottom. Right, so that's why I think that's what you mean by that. How is 1/2 squared 1/4? Yeah, so let's see, where are we? Yeah, 1/2 s squared, 1/2 s times 1/2 s. 1/2 times 1/2 is 1/4, and then we have s squared. Okay. Somebody is asking for the homework. Look on the syllabus. Here's the homework for the entire semester, right? So 1.1, here's the problems. You say, hey, I already did a lot of problems. That's right. So you just have to go back and study it on your own. Okay. So yes, most of my lecture, I'll just be doing problems from the homework. I could change it and not do the problems in the homework, but this makes it easier for you guys, right? Yes, people trying to add, do everything up to 57. Well, you already did 10. So let's say 13 through 57, the problems that I didn't do. People trying to add. If you're already in the class, this does not apply to you. You're good. Okay. Then, still do the homework. Just you don't have to submit it until the day of the test. Okay. All right. I think I've caught up with the chat. If I didn't catch you in the chat, send me an email. I apologize. I know some of you were asking about attendance. I'll look at the chat a little bit later also, but otherwise, send me an email about that. Okay. Any other questions, please? Otherwise, we're done for the day. All right. That'll do it, folks. So everybody have a good day, and we'll see you all tomorrow. Okay. All right. Bye, everybody. Have a good day.
Thank you.
Thank you.
Thank you.
Thank you.
it's just like a general question.